Guys, let's start. Um, so before this class, let's do a brief introduction about where we were. We did relational databases. We treated it separately, right? And we said for the most part, how you create relational databases in AWS is the same, right? For the most part, you basically just choose the engine, right? But the management is the same. There's usually like the database, you choose an engine, but how the logs are kept, everything about the management from the AWS perspective stays the same, right? For you, it's just a matter of choice. Which SQL database do you want to provision? So it's about database in the cloud. We also said not everything can be solved by relational databases. Sometimes you really want to use databases that don't force you into like it doesn't force you to more or less like create those tables, create those constraints. Relational databases, they also have where they shine, but in some cases it's better you go with a no SQL database, right? So DynamoDB is one very good option, and we saw a bunch of them. But again, outside databases, there are other things that happens, right? So all the database we've looked at, you're talking about transactions, but sometimes there are times where you now need to do analytics. So analytics is a very different ballgame, right? Sometimes you want to generate report, sometimes you want to stream data. All that is not, it has nothing to do with all the databases we've discussed, right? So in this class, we're just going to be looking at the options, the many options that are there for you to do analytics in the cloud. And I think I've also mentioned it, for example, someone who is already doing data, this is like a segment that is important to them, right? Because data involves, sometimes getting those data, doing some analysis on the data, storing it somewhere for consumption, right? And we'll see all those options that we have in the AWS cloud. So what's the learning objective in this class? We basically want to talk about OLTP as it differs from OLAP, right? So the difference basically we're going to see, and then look at Redshift, how it helps us with warehousing. Look at Athena, which is obviously one thing I'm going to share here. Talk about how QuickSight can basically help you with more or less like your dashboarding and your BI. You can also see the process, like when you process streaming data, the options that are there, right? Looking at the Kinesis family. And then we'll see how those different pipelines, how they work in the AWS cloud. Okay. Um, so when you now think about OLTP versus OLAP, everything we've talked about has been OLTP, right? We've been talking about transactions, right? Online transaction processing. So it's more or less like someone is shopping, doing like interacting with your shopping cart, they're saving things, you know, all that is really transaction, right? Your processing is basically CRUD operations. Maybe a user is shopping on your website, is interacting with your cart. So everything you're storing in the database is about the transactions that are happening within your system, more or less like operational databases, right? But again, that's where analytics differs. So when you talk about OLAP, so that's the really major difference between all the databases we've seen before versus what we'll be discussing today. It's really analytics and reporting. Analytics is about analyzing data, right? Whether it's real time or near real time, but it's basically you're getting data, you're doing some sort of transformation, you're still storing it in a different place where it can be, analyzed, right? It could be for reporting, it could be for data aggregation, right? So OLTP is basically fast transactions, right? Normalized data, row oriented. So row oriented is something I really needed to pay attention to. When you look at database data, one key thing in a database data is normalization, right? But again, this is not a database class. Usually we'll have to normalize data. It's row oriented. We've discussed that. And then you needed like very complex queries, right? To do some major things around OLAP kind of databases. But when you now go to OLTP, it's really analytics at this point, right? Um, if you think about okay, I think I was talking about the way it's written is a bit all over the place, but OLTP, like I said, is really like orders, user registration, your cart, right? But when you think about OLAP, the examples there is basically sales, right? You want to report, you want to do trend, you want to do data mining, basically aggregating data and doing something with it. That's where OLAP shines, right? So OLTP is basically fast transaction, like I mentioned, normalized data, row oriented. But you need to think about OLAP. How does it differ? Complex queries. So when you ever want to think about complex queries, OLAP shines there, the normalized data that doesn't really care about like those foreign keys that you need to keep, right, within those tables. And then things like it's column oriented. So think about one is row oriented, the other is column oriented. And the reason is just because for analytics, you care the most about aggregation, right? So that happens. Um, that brings us to one of the databases in AWS that can help you do analytics, and it's Redshift, right? So it's fully managed, meaning, like I've said, many of these requirements, many of these things, people already do it before the cloud. So in this case, we just have now a platform that allows you to do huge analytics in the cloud, right? So more or less like heavy data warehousing. So if you had like a warehousing need, Redshift can do that for you. One thing that sets it apart is basically it's a columnar storage, right? With massive parallel processing. the idea is that it differs from how your traditional database is stored. On the line storage, it uses row, right? Row in the sense that just the way the database is, where the items are stored in rows, that's how in the storage they are stored like that in blocks, right? But when you switch to a columnar database, instead of doing that same storing those rows in blocks, rather you're storing columns. So it's more or less like one column of storage would have things around an item. So for example, you could just go to that column and get everything related to cost, right? And it shines because when you look at how analytics databases work, they really shine when you want to do aggregation. So it's easy for you to just go to a column. If I wanted to get all sales, like all the total sales, right? Instead of me having to go through all the rows, right? In terms of traversing all the storage, I can just go to one column and fetch everything out, right? So petabyte scale data warehouse capabilities, Redshift will give you. And the beauty of it is really, it's a warehousing database, but everything you still do is still like standard SQL queries, right? So all your standard SQL queries will still work, right? But now you are using a warehouse that is basically optimized for your data warehousing needs. So regardless of how much data you have there, you are more or less like sure that regardless of the complex queries you want to run, it's going to run, right? And you can have it done very, very fast. So it's actually 10x faster than traditional database for analytics. So if the same thing you would have done with your traditional database, if you do it in Redshift, it's going to be 10x faster, right? So it means that for your analytic needs, there's no reason why you should do it in SQL, or like you need to do it in Postgres or MySQL, right? Redshift is really tailored for that. Um, it's also you can integrate it with data lakes and do real-time analytics, right, on the data store. SQL-based queries, like I said, with standard BI tools, so business intelligence tools and Redshift. So whatever business intelligence tool that is out there, AWS has quick site, and we're going to see that. But there could be other business intelligence tool that you can put on top of Redshift for you to more or less like make informed decisions from your data, right? And then obviously the Redshift query editor. So when you now think about Redshift, there is also an option for you to go serverless if you ever want to deploy, if you ever want to go the serverless route. And we know, right, the fact that Redshift on the other hand, you needed like, it has a cluster, it has nodes that powers all the operations that you're going to be doing, but you can as well just go without using any infrastructure, like not provisioning infrastructure from the start, right? And just forget about the infrastructure management completely. So it scales with your compute capacity, like it basically scales, right? Up and down for you as your need goes, and then you only pay for the compute used during queries, right? Remember, it's all about queries. You have data. At some point, you have to load the data into Redshift, right? And then the computation happens when you do like heavy queries, right? I know some of us, we are used to like small queries, but imagine you are dealing with petabytes of data in a database, and you have to do like you have to more or less like do joins to bring those data out, right? That's where you hit some limitations with the traditional databases we've seen compared to like a database like Redshift that is built for warehousing, right? So workgroup-based resource isolation is also one of those options there. You can automatically pause and resume, right, during idle times, meaning when you're not doing anything, you can basically pause it. So ideal for variable and unpredictable workloads. So the thing is that Redshift is really purpose-built database for your warehousing needs. It's definitely going to do way much better than what you will gain from a traditional SQL database, like the ones we've seen in the past. And then you can have two flavors of it, right? So the serverless flavor and the non-serverless. Okay. So at this level, I'm not going to stress on Redshift for now. At some point, we'll talk about Redshift, but there are other things we can talk about. So when you now think about Redshift is native to AWS, right? That's like AWS product, right? But again, you should know that warehousing, when you talk about big data, before the cloud, there were ways people do it, right? And so if you now wanted to do it in the cloud, in the AWS cloud, sometimes you are dealing with AWS native tools, but sometimes you're also dealing with tools that is already out there, but supported in AWS. And that is a good example of EMR, right? And it's called Elastic MapReduce. And the whole idea is it's built on Hadoop Spark, right? Which is an open source framework for big data, right? So Hadoop/Spark, it's basically a big data framework, and it's known outside of AWS. So, but if you actually want to have that in your AWS ecosystem, then that's where you need an EMR cluster, right? So it's a managed cluster platform for like big data frameworks. In this case, Hadoop Spark, and obviously it's supported, like it's made up of several EC2 instances. So you're doing like very, very big data on top of like so many EC2 instances. So an EMR cluster itself, it's made up of so many EC2 instances that it's powering it behind the scene, right? So it supports Apache Hadoop, Spark. I think these are terminologies you will know if you're already doing Spark. But I'm just saying that if you wanted to have more or less like a replica of this solution in AWS, you can use EMR. Elastic scaling with EC2 sports instances. Remember, it's made of so many EC2 instances behind the scene, right? But you can obviously use spot scaling, spot instances to also power that workload. It's integrated with S3, DynamoDB, and obviously other AWS services, as we'll see. Where do you need it? ETL, right? Extract, transform, load kind of operations, processing, and then machine learning, log analysis. Um, so the whole idea is that if you actually want to do anything around Hadoop Spark, there is really EMR that can get that done for you. Okay, so we won't touch very deep at this point, but just so you know, if you were doing anything around CCP and you come across anything that has to do with Spark and Hadoop, obviously EMR is a tool. It's just a cluster. It's an Hadoop cluster. You're also hosting in AWS to more or less like meet your Hadoop needs. Okay. Okay, that brings me to some of the things that I love to talk about, and that's Athena. So Athena, on the other hand, like so the other clusters, Redshift that we mentioned is basically you can do same SQL, right? But now using an analytics database, and it's for really when you are doing massive parallel computation, right? And then we talked about EMR being a tool itself for you to do Hadoop Spark. Just bring your Hadoop Spark into AWS. An EMR cluster can allow you to do that, right? But there is also another tool, basically serverless interactive query service that AWS has, and it's called Athena. What it does is that you basically could run SQL on top of any data that you have, right? Especially supported schemas, right? So you can upload just your S3 file, for example, and then you're running SQL, right? Everything we've talked about is kind of related to like how you do like your queries and all that. But in this case, it's like a serverless database. You're not really keeping one database somewhere, managing it. You basically just can run the SQL on the fly on your data, right? So your data is stored in S3, it could be in JSON, it could be in CSV, and then Athena can just help you just immediately just do analysis on the database without you on that data source without provisioning anything, right? So no infrastructure management, no infrastructure to manage your provision. You only pay for like how much data is scanned during your query process, right? And then you can basically do standard SQL queries, right? So, and it also integrates with QuickSight for visualization. Um, so when you think about the architecture, right? So uses Presto distributed SQL query engine, automatically parallelizes queries across multiple nodes. So it does that all. It does all this behind the scene, and we're going to see it for you in this class. But it does it behind the scene, right? So you just give it the data, and you want to run SQL query on that data. It is smart enough to know how to more or less like do all the parallelization that it needs to do just for you to get the result you require. In this case, you are for the most part interested in the result, right? Supports various formats. So CSV, JSON, you can have files in Parquet and just load them in Athena straight out of the box and have your SQL already doing beautiful analytics for you, right? Columnar formats obviously provide better performance. And if you see, that's what differentiates Redshift from your OLTP databases that we've seen, right? Columnar storage versus row storage. Please, you can read more about it. It's very important you know the difference between row storage versus columnar storage. So Parquet is basically a columnar storage. And so if you wanted to optimize your storage, even make Athena perform better, it's better if your files are in the Parquet format, okay? And again, partitioning also helps, right? Because if you have data and you partition it, what it means is that instead of going to like it's just trying to scan remember you're paying for how much data you're scanning. So instead of scanning the entire data, you can scan based on partitioning, and we'll see that. So you can actually partition your data so that when you're trying to request data, you can actually go to the partition to fetch the data instead of scanning the entire data set. Okay. Data compression can also help to reduce the scan cost. Remember, for Athena, you're basically paying for how much data was scanned. So your ability to keep that data minimal, the data that is scanned, which means let it know exactly where to get the data. You can actually shy away from paying so much. Okay. So what's the use case of Athena? So ad hoc analysis of logs, right? Your logs are written in different formats. You can pass all that to Athena and just do queries on top of it. Business intelligence and reporting on S3 data lake. So if you have like data in S3 and you wanted to do BI or like reporting, you can basically use have a BI tool that uses Athena as the backend. Okay, there's a lot of applications of that, right? Cost analysis, yes, usage and billing data. So the billing data you don't see. If you go to the console, your cost explorer, you will see a place that breaks down how much you are spending, but you can actually get that data in CSV. And what it means is that you can query that data with Athena to have an idea of how much you're spending and all that. So you can do a lot with it. ETL pre-processing, right, before loading into other systems. So if you have like a data you're monitoring, you can fetch that, push it into Athena, run query, save the results somewhere again, right? So basically you can do anything. And the pricing is basically by the number of terabyte that is scanned. So how much terabyte is scanned. So Cost of optimization in terms of Athena, use columnar format, right? Columnar storage, which Parquet support, and then partitioning, right? So instead of having it read massive, read all the files that you have, it basically can read based on partitions. Okay. So I'll show you what Athena looks like right now, and that one is easy for me to show at this level. Okay. So I have a database here. It's basically empty, right? So sorry, I have an S3. My S3 here is empty, so I'm going to start by creating an S3 bucket. So the bucket I'm going to create here is I'm just going to create a bucket. So I'm going to say I'm going to call it. I think we already, at least I'm talking to everyone. Everyone on this class already knows how you can just create a simple bucket, right? So I'm just going to create a simple bucket here. I'm going to leave all the defaults. Versioning is not enabled. I'm just going to take the default and just create a bucket, right? So I have a bucket created. So now I want to upload a file, right? Think about it. This is like it's a file. Maybe I got it from the internet. Maybe someone sent it to me. It's basically one of the files that is supported by Athena, like we've seen, right? So in this case, I'm just going to be uploading. I'm going to upload a. So if I go to customers, I already have like an 001 folder and an 002 folder. The 001 folder is basically a CSV file, right? So if I open, it's a CSV file. Let me upload it first. So I'm just going to upload it. So it's been uploaded because it's a very small file, right? But this file, as small as it is right now, it's small. It could be big, right? It could be very, very big. It could be a big, very, very big file. Let me see. Just trying to see if I could actually just view. But again, it's going to download it, so I'm not going to care. So think about it. I have a file, and I want to just run an analysis on the file. That's where Athena comes in, right? So I don't need like I don't need to do like specialized database or whatever. I can just use Athena right now to query this data. Remember, it's small data, 16 kilobyte. But in the ideal world, it could also be 1 terabyte of data, right? It could also be 500 megabyte. It doesn't matter, right? Since I now have a bucket, I'm just going to go to Athena and do. So if I go to Athena, it's here. You get this UI. There's like a data source, which is the AWS data catalog. But you will notice that there's a database, right? There's like databases, and there's like the default database, but I can also create mine, right? So I can actually just run a command here to create a database, but I also want to show you where those databases are actually managed, because we'll see what it is at the end of the day. But let's go to Glue. Okay, so we'll go to Glue, and then in Glue we'll go to databases. Right, you see that the database that was there is still showing. It's showing this database, so it means that you can actually manage your database. So I'm going to call one Brainium. I'm creating my database, right? So database for Brainium. I can actually create that database in Athena by just running the create database, right? It's basically SQL. I'm just going to create a database. So a database is here now. And then if I come back here and I refresh, you notice that I now have a database here, right? So there is now a database. So what do we want to do? I want to now I have a database already, right? Brainium. Now I want to use Athena to just write a script that would fetch that my S3 bucket and just create a table of it, right? So create a table of my S3 object. So what I'm doing here is basically, I think I already have an idea of what is in there, right? So that CSV file that you see, it has customer ID, first name, it has all these things I know beforehand. And I'm saying that I want you to use the Brainium database, call the table customers, right? And then I'm saying, use this format to basically pass the data. And then location of what I want to fetch is this bucket / customers, right? And then all these are basic stuff. So if I run this command, right now, if you see tables, they're actually 0, right? So if I run this command, you see it's completed. And if you see here, there's already customers table, right? So I can actually come here and so I run this command. I can also do preview. So if I do preview, settings, manage. Yeah, I think my results are actually there. So let me just go back to it and be sure that, okay, it's using it. So let's go back to Athena. I think I'm here. I'm not sure why it's not even loading anything now. No result found. It did this. Let's see. Create the database from here. I'm just trying to be sure that the properties are the same, but it is, because for you to see that, let's go to. Oh, okay. I made a mistake. It's basically different. So if you see the part I gave, I was supposed to create a customers folder. I did not. So that's the mistake. So I'm just going to create one quickly. Okay. because I actually want to use it to show something. So that's why it has to be in that format. So I'll create a folder. Because in the ideal world, your data will be partitioned. It's going to be broken into more or less like groupings, and that's why we talked about partitioning. Because the whole idea is that you can actually let Athena or Glue, for example, know the partition to go and fetch data. Okay, so that's why. So I'm just going to move this file. So here is I have a folder. I'm just going to move this file. So I'm going to move it to the customers folder. So I'm just going to browse this, and then I'm just going to do customers, right? Choose destination, move. So if I go back to S3 and I go to that customers folder, there is now that file. So what I did before, because the script I had before was targeted at the customers folder. So now, although if I run this again, okay, I think it ran again. So let me do a query and see. Yeah, so now it's working, right? So you can see that quickly I can just do run. I can basically run query. And all of a sudden I can get all the files that is in that, like I can get basically I can run query against the file. That's just the whole idea, right? Serverless SQL on top of your data that is in S3. In this case, it was a CSV file. It could also be JSON. It could also be Parquet, right? So all the format supported by, so everything like, so I can comment this, and I can do things like select. So if you wanted to do like analysis, right? So I could do select count, from customers, right? Because I'm already in that database. So whatever beautiful things you already knew from the standpoint of yeah, you can. So it tells me that I have, right, 100 records. So if I go back to more or less like the previous query, right? So if I go back here and I just uncomment this to get the first 10, right? And then I can just what is this one? Limit it to select star from limit 10. Okay, so I can actually just do select. I'm not sure why that one is not select star from customers, right? And then I can limit it to 10, for example, right? And then run this one. It gives me this one. What if I was interested in? I mean, this is pure. So I was interested in where the last name was Basta, right? So last underscore name is Basta. So I can say I can comment this one, right? And do select star from customers, right? Where I think his last name is equal to, right, Basta, right? So I can do this and just run this query, and then it gives me one result. What are we doing? We had a data that was in S3, right? It was a CSV file, and immediately we were running analysis. We were running analysis on the data, right? We just fetched it, like we just brought it straight to Athena, and we're already doing query. Like I said, this is a very small example, but it's the same. If you had like a massive file that is a CSV file, you could come here, do your analysis, and there's so many places it can be helpful, right? Whether you're a data, obviously there's so many data like analysis tools in AWS, but Athena is one, right? And there's so many benefits. The fact that you can just take a file and then you can do query analysis on it. So we've seen one sample, right? But there's something else I want to show. So if you notice that this is one file. So what I'm going to do, I'm going to upload a new version of that same file. So I'm going to go here, upload, and then I'm going to add files. So before I uploaded from 001, but this time I'm going to go to 002 because there I've already added a new column. So I've added a new column to that file. So I'm just going to do upload, right? It's here. It's the same customer.csv file. So it's going to overwrite the file that I already had there. So I'm going to upload it. So right now that file has already been updated, right? But the thing is that if I run all the command that I've been running before, like I go, I comment this and I do this one, right? So I'm just doing the first 10. One thing you notice is that it's not going to show the last column that I've added, right? It's not going to show. There is a new column in the new data that I've updated, but it's not there because that file, that column is not being seen. I can fix that. I can basically run a command to say, I know in the S3 file there is already a new column. You are just not showing me, and I want you to show me, right? So I can go here, comment this one, and go here and say alter the table customers, add column account underscore status, and make it string. So I'm going to run this command. Cannot recognize alter table customers, add columns. Yeah, what is it saying now? Okay, let me say this. Yeah, it's basic query. I'm not sure why it's not. Yeah, sometimes I don't know. It looks like, yeah, I had to select these two. Like I had to just select it to execute. Maybe there's something. But now it has executed. So what did I do? I just altered the data, the customer table, and I added this column account underscore status. Now the thing is, if I go back and comment this one, and I go back and do select star from this, Especially this, let's even run this last command that we ran before. So let's run it, this one. What do you think we're going to get? If you scroll down, we now have a new column that says account underscore status is inactive, right? So I'm doing all this from Athena. I didn't need to create like a database that I'm going to be managing. I just had a JSON file. I just had a CSV file, and immediately I just brought it into Athena, and I'm already doing query and analysis on it, right? So that is one way to do it, and Athena is just that too. You can basically run serverless SQL on top of your data, right? Whether it's from JSON or SQL. But there's something that is missing, right? Because notice how when the file changed, I'm having to do more or less like altering the table again. I'm already running the command to alter the table, and then I'm going back to re-execute, the query again, right? Just to make sure that I'm getting that new column. We will see how that can be fixed easily. Okay, there's another option for us to use. But Athena, that's basically Athena. The file source is always in S3. One of the data source you can have like is S3, and then you can just pull the data in and run SQL immediately on top of that data. Okay. So let's go back to our slide, and then we'll see how that links into a new topic. So we've seen Athena already. So that's a good segue into Glue, right? Glue itself is like ETL, basically. So extract, transform, and load, right? We saw how we just brought a data, like it's a file that was already CSV. We just brought it to Athena, and immediately we're already running SQL on top of it, right? Without creating our own database, having something to manage. So under the hood, it knows how to provision the right resource to do exactly the kind of things we want to do. But there is also Glue, right? Glue is a mix of many things, but I'm going to show you one part of Glue that solves the problem that I was just showing you with Athena just now at some point in this call. But it's really serverless ETL, right? Serverless means, you're not provisioning you're not managing any server or maintaining any machine. But the most important thing is really you're extracting data, and sometimes you need to run transformation on those data, right? So it's like an ETL, is an ETL service, right? So you can have Python, have your Python code or your code in your programming language, Python or Scala, to basically do all those transformations that we're talking about, right? You can also have like visual ETL job. So there's the concept of Glue Studio where you can go there. You can basically from the UI just create visual, like see a workflow and create visual workflows and do very advanced stuff. Okay. Glue itself is a very big subject. Okay, but we'll approach it gradually. There is built-in transformation for common data operations. So if there was already something that that is common, you can just basically do it in Glue. Auto scaling and pay per use pricing, right? So like I said, you don't really need to manage any capacity when you're dealing with Glue. Integration with various data sources and target, right? So the whole idea is that you're basically loading data from somewhere, you're doing transformation on top of it, and then you're obviously saving it again somewhere else, right? So, and that brings us to, so we just looked at the jobs themselves, but that brings us to Glue data catalog, right? Because it's something you can't talk about Glue without talking about data catalog, and it's the fact that you have like a centralized metadata repository for your data set. If you think about the data we're working with in Athena just now, we were having to do the column discovery, the management ourselves. We were doing all that, right? But you can do that with Glue catalog. So what it means is that Glue catalog can actually fetch your data, and it can actually create all the metadata and everything that you need. So all those columns that we're trying to describe, it can create a catalog for it, and then it just makes it easy. You don't have to do it yourself. So that's really the second point. Automatically discovers and catalogs your data schema, right? And crawler can actually is something. So it's also a feature of Glue where you can use crawlers to get the data, categorize them or catalog them, and then you can just run the same Athena queries that we're running before. So tight integration with Athena, EMR, Redshift, and other third-party tools. Version control for schema evolution, and that's one of the benefits you get, right? You can see over time how your schema is evolving. When you saw that I added account underscore status, that was an evolution, because initially when I added the data, it wasn't there. Account status wasn't there. At some point, I introduced account status. So all that can actually be managed for us with Glue, with you not doing anything, right? Data lineage and governance capabilities. All those are features, obviously, at some advanced points that we're going to see. But let's go back to Glue. And let's go to the Glue dashboard. So here we are. I'm going to retain the database. I'll leave these queries that I have, right? I'm going to leave these queries, but I'm going to delete the database. So I'm just going to go here. Okay, I'm going to leave the database. What I'm going to delete is the table. Remember, I had to run a query, this one, to actually write the table. But now I'm going to ignore this query. So I'm going to even close this query completely, right? Close this query, but I'm going to leave this one because I still want to process that table, right? But now the table is here already, and now I want to delete the table completely. So I want to delete the customers table. I don't need the table because there are better ways for creating it. So I'm just going to delete the table, right? So the table is gone. So any of these queries that were here, so you can see it's drop table command, right? Same SQL that you know. So that let's now go to Glue. So if you go to Glue, right, you see on the left there is like some things you see, right? You see ETL jobs, you see data cataloging, you see zero ETL. Honestly, Glue itself is like it's like a very massive tool that you can use and very fun to work with. Okay, so yeah, Glue itself is something we don't want to go like in depth right now, but I'm just going to show you an interesting part about Glue and how it solves the problem we're trying to do before. So let's go to crawlers, right? So the whole idea is that you know that we push file to S3, right? So you push file, and there was like a change. There was at some point a new file was uploaded that had like the original, that had a new column status, and then we had to alter our table to do other. You don't need to do that with a Glue. A Glue crawler can crawl that data with Glue, and then do automatic schema discovery for you, and then you can basically just immediately query that data in Athena. Let's see how it works. So let's go back to our file. So we went to customers before. Remember, this is V2, right? So I'm going to go back and upload V1 just so that to make it easy to explain. So we'll go back. So this is 002. I'm going to go back to 001, revert it back to the 001 version. So I'm going to create upload. So we're back to 001, right? So this is the one that had no column status, right? So it didn't have account underscore status. It's not here for this file. So what do we need to do? Let's create a crawler. So we are just going to call it S3 crawler. That's the name, right? So crawler is one thing we're going to do. I'm going to call it my S3 crawler, okay? And then I'm just going to do next. So this is where it's important, right? So the thing is, I need to create a data source. I need to tell it where is it going to crawl the data from. So I'm going to add a data source, all right? So you can see so many places you can crawl data from, right? So there are so many of these data sources I can basically just fetch data from. But in this case, I'm going to be using S3. So it's saying JSON, CSV, or Parquet file stored in S3. So I'm going to use S3, right? It's asking me where's the location of the S3 file that I want to query. In this case, I'm going to go here. It's customers, right? So I'm going to choose customers. Once that is done, I'm saying crawl all subfolders, just basic setup. And then I'm going to go next. This is where it asks me for a role, right? So I'm going to tell it to create a role for me. So here I'm going to call it S3 crawler, right? Just to be sure that, yes, it's actually a crawler it's creating. So the role has been created. And if I go and view that role, let's see what that role looks like. And there's one permission that I want you to pay attention to. And that's why it's good we've built some of the foundation we've built, right? So if you see one of the permissions you see is that there's already a permission that says in this particular bucket, be able to get object and put object, right? Basically, that's what the crawler is doing. So it's saying you can get object and put object for this particular bucket, the account, forget about the condition, but these two are the most important, okay? So it means the role is already added for us. We're just going to do next. Choose database. So it means that when it crawls the data, where is it going to take it to? So here I'm just going to say use my Brainerd database that I created. Right now, prefix is optional. Advanced option is where I want to say create a single schema. So for everything that you see in that customer, just use one simple schema for it, right? And then there is an option here that says update the table definition in the data catalog, right? So whenever there is a change, really, it's going to do the schema discovery and update for us. So I'm just going to do next. If I go back to previous, you can see there is like on demand, right? So you can actually even set a schedule for this. In this case, I'm saying on demand, meaning I only want this crawler to run when I need it to run. Okay, so I have it set on demand. I'm just going to create the crawler. So the crawler has been created, right? So if I go here, there is a crawler. If I refresh this page, there is really a crawler, right? It's ready, but it has not been run. So I'm going to come here and I'm going to run the crawler. So the crawler now is running. So let's give it some time to run. And if we go back to Athena, you will notice that here, we still don't have any tables just yet, right? So it's like zero. We didn't create any table. Right? We created one before, but we deleted it. We are replacing it for a glue crawler to do for us. So we'll just stay here, give it some time. It's still running. It's going to take its time. And it's not going to take a lot of time because the data is small, right? We just have like some kilobytes of data, but let's give it some time to run. But one thing you will notice is that some of these things are going to change once the crawling job is done, okay? So let's wait. If you go to the crawler, you basically could see things like when it's run last, you can see the schedule. In this case, it's on demand. So what it means is that we have to click on it. We have to run it every time we want it to work, right? But you can also do it as something that is scheduled. Maybe you want to change, you want to run it every, give it like a time frequency. There are other advanced settings that I don't want to care about right now. But let's go back and see the crawler. So it's still running. Usually it takes some time, but let's let it do its thing. The most important thing is like we have a role that is already, the trust relationship is going to be used. Glue is going to assume the role to do its thing, and it already has permission to basically fetch data from the S3 bucket, right? That's the most important thing we need to care about. So you can see the status is stopping, right? It's stopping. So it's done crawling. But one thing you notice is that it has created one table, right? So it means that it went to the folder that we gave it. It saw the JSON file that were there, and it created the table of it, right? So what it means is that while that is running, I can actually open tables on the side, right? So one thing you'll notice is that there is now a new table. So it says customers. That's the table. It shows me the location of the table. It was gotten from /customers. It knows the type CSV, right? The table data, obviously, if I do table data, it's going to take me to Athena. But I'm not going to do that now. Rather, I'm just going to click on the table itself. And then this is where the beauty comes in. Did you notice how, we already have a schema, right? This schema were things I had to provide to Athena at some point at the beginning. But here, the schema is already in fact, right, from the data. Obviously, there's no partitioning in there, but you can do more advanced things. But what I'm just saying is that automatically it was able to discover the schema. So the question is that if we go back to the queries we were running before, so what is going to happen? So let's go back to Athena and then refresh this page. Let's do a refresh on this page in Athena. So one thing you notice, a table is back, right? The same table we created manually is now back. And the question is that what about the queries we ran before? We did not run. So let's do, for example, this one that says select star from customers. You can see, yeah, it's there. The same queries that we ran before is now running, right? But we didn't have to do anything. We just created a crawler to do that job for us. So we can go back here, we can do this same query that we ran before, we can execute it again. This case is just counting, right? So it's also working. It's also working. And then we can also do, yeah, I don't think we need to do this one. What about this one where we're selecting where the last name was Basta, right? So we could do that. Yeah, we're getting it. But one thing you notice is that, yeah, it's still giving us the old data, right? But remember, we have to do this update column status at some point. Now I'm not going to do it again because I have a crawler doing that job for me. So what I can do is that it's ready. It tells me it's ready. I can go to the logs to see exactly what it did, right? So you could go to, I think this will take us to CloudWatch. You see all the logs that happened when it was trying to crawl the data, right? It tells me everything that was happening. So if your job was failing, this is like a good place to see why is it failing. So what do we now need to do? Let's go back to our file, customer, right? Let's upload a new version. Okay, so the same thing we did with Athena before. We'll now go to add files, and then we will go to 002. So I'm just going to go to 002 and upload. In 002, a new column has been added. I know that, right? Because I prepared the data. So there's a new column added. But if I go back to Athena and I do select this, I run this command, it's not enough. Like it's not going to show immediately. We saw that problem too with Athena, right? It's still not going to show. You can see in the other column, there's nowhere it has account underscore status, right? So which is one of the reasons why I can now go back to my Glue crawler that I had already created, right? So I had a Glue crawler here. The thing is that remember we did set it as an on-demand mode, right? So it means I can go back here and run it again. But if you're already looking at this, you know that because we're doing it on demand, we could also do it on schedule. We could also do it based on an event. It means that when there's a file uploaded to S3, you can already build an ETL pipeline that says once a file is updated to S3, trigger this Glue crawler, right? Run the crawler, to do its thing and then update the table. And then wherever that table is being used for analytics purpose or business intelligence purpose, it will get the fresh data out of it, right? But let's give it time for it to run. So the crawler is running. Right now, it's not specifying anything here saying any data has changed, but let's give it some time, okay? But I know that in the new data that I uploaded, there's really a new column. That's really what I want to show. And the fact that in Athena, we have to do all that ourselves. We have to more or less like create that management. And that's where like Glue cataloging, that's where data catalog for Glue comes in because the schema discovery happens automatically, okay? So let's give it some time to run. But if I still go back to my query, like if I was doing this, if I was like running the same query, I'm still going to get the old result. So if I run again, right now, there is still no new column, right? Because the crawler is not done with its job. So let's give it some time. And remember, we're also somewhere. We're looking at the table, right? So we were here. We were looking at the table. We only had like 12, I think we only had like 12 columns, right? So let's go back to the crawler and just give it some time. Okay, you can see one table. So one updated, right? It means that there was an update. So when it ran the crawler the second time, it knew that something had changed. So what it means is if I go back here and I refresh this table, if I refresh this table, one thing you notice is that, I think, I'm not sure if there is like a place to refresh. Let me just refresh this entire UI. But one thing you notice is that if I scroll down, can you see how there is now an account status, right? So this wasn't there before. This was automatically discovered by Glue, right? So Glue discovered this. We had to do this manually in Athena, but now because we have a Glue crawler that is able to see that file and infer the schema, it is able to just do all the update for us. So if I go back to the query, for example, and I run this same query again, and I run this, so one thing you notice is now there's going to be a new field that says account status, right? And so what it means is that I can actually do select star from customers where the account, now it's discovering that column now, right? So I can see where the account status is inactive in this case and just run this query, right? Now I have like 11 records where the the account status is inactive. So the thing is that one thing you should understand about how this works is that it's really the idea. We're still talking about analytics, right, in the cloud. So everything we've seen before has been traditional. Like we've talked about relational. We also talked about like NoSQL for data that falls around that range, like around that use case. But here we're talking about when you now want to do analytics, right? Business intelligence. Sometimes these things don't happen real time. And sometimes the data is somewhere, but you want to now do more or less like some aggregation, some transformation, and then do a set of operations on top of it, which is what we are doing on Athena, right? But if Athena can already do that, it means that you can even build something on top of Athena that can do maybe display graphs, do business intelligence for you. Okay. Yeah, but you can see how we're able to achieve that using both Athena and then using like a glue crawler. But in the ideal world, is a glue crawler you're going to use, because one thing you understand is that for the schedule right now, we're doing on demand, but you could actually build a schedule. So you could have an event that is tracking when there's a new change, and when that happens, you can do a glue crawler to run the job again and then refresh your data catalog, right? And whoever is doing the query on the other side, they can basically just fetch the data as like fetch the most recent data. Okay. So let's go back to our slide. So those two were good to share. So we've seen the data catalog. That's really what I showed you, because the catalog was created on our behalf. Like it was created automatically. It was discovered automatically. You could update the catalog if you wanted. You could, but it's going to be created for you automatically, and then you can do. It also grows with you, right? Because you can, when you push in new files, it can actually update the catalog, right? So when you now think about QuickSight, what is now QuickSight? If Athena is already fetching the query, you already know that you can run those queries, right? It means that, yeah, the data source is sorted. Whatever brings in the data to Athena is already sorted. Now in Athena, you could basically just build a UI on top of it, right? And that's where QuickSight comes in. So you can actually have business intelligence on top of that data, right? And behind the scene, obviously, you can use Athena to run the queries that QuickSight is going to use, right? So fully managed business intelligence service, right? And then interactive dashboards and visualization. So that's all the idea. Like you just have a dashboard. All the things that I was doing just now, I was doing count. I was doing count of customers. I was doing customers where they were inactive. If you needed a dashboard for you to present all that, right, you could just use QuickSight. Auto scaling from 100 to 1,000 users. Yeah, QuickSight is basically per user, right? So mobile ready with responsive design, which means, yeah, whether you're watching it, you're using QuickSight from your laptop or from your phone, you get that mobile responsive design. Per session pricing model, it integrates with RDS, Athena, S3. We just saw it, right? So if Athena can fetch that data from you, you basically can put QuickSight on top of it for you to visualize your data, right? And then some external data sources if you want. So there's no big deal about QuickSight. It's just an intelligence, a business intelligence tool that you can put on top of where data is coming from. And we just saw a very practical example, right? It could be from an S3 file, and the Athena can already query efficiently, and then you can build like a QuickSight on top of it to display the data to an end user, right? Obviously, there are some features QuickSight has. It uses obviously the Spice engine. There's not much to say around that, but super fast parallel in-memory calculation engine, right? That's really what powers the search capabilities of QuickSight. You can also do like natural language queries with the Q&A feature for QuickSight, meaning, and obviously that's where the world is going, right? I think we've gone past the age where people are writing manual queries. These days, people want to ask questions like, how many customers do I have? Like I type, how many customers do I have? And then you get results. So instead of you understanding how to write SQL, the world is obviously evolving to the point where people can actually use natural language to get data. So I can say, can you show me all the customers that are defaulting, right? And then it just knows which query to write. Okay, so this is just talking about some of the ML integrations with QuickSight, right? Anomaly detection, obviously powered by machine learning, forecasting, embedded analytics for applications, and then row-level security for data governance if you wanted to use that, right? So these are all just some advanced features that is built into QuickSight. That brings us to the stream family, right? If you think about what we just did right now, there was like a file, right? It's in S3. We used Athena at some point to get the data, and then we found an intelligent way of using a crawler to do all the updates and the schema updates, right? So that the query will still run whenever you run it and get the latest file from it, right? But there's sometimes you really need to stream data. Even this aggregation that we're talking about in S3, it could be from streaming data, right? And that's where streaming comes into play. There's so many things you might want to stream. It could be data, it could be video, it could be audio, right? So there's really data stream. There are two streaming services we're going to talk about. The first one is really Kinesis data stream, and it's real-time data streaming service. It captures and processes data records in real time. So it means that, yeah, basically real time. As the data is coming, you're capturing it, and then you can also process it immediately. Scales to gigabytes per second throughput, right? So yeah, you can scale. There's a concept of shards that you can basically have that scales your data. Retention, it starts from 24 hours. You can retain data for 24 hours, and then you can You can extend that up to 365 days. The whole idea of how Kinesis works is that it's streaming data, it keeps it, and then your producers are producing the data. Kinesis is there collecting the data, and then your consumers are also somewhere consuming that data, right? But in between, there's like a storage layer. So that data is stored in Kinesis data stream until it is taken away by your consumers, right? So producers on the left, consumer on the right, and then so multiple consumers can process same stream, right? So same stream data, and then use case real-time analytics, monitoring, fraud detection. So just understand that Kinesis data stream is really there to answer your streaming needs, right? So if you wanted to stream, if you were thinking about real-time streaming of data, you can use Kinesis data streams, okay? And that brings us to Firehose. And sometimes there's this confusion about Firehose and data stream, right? So Firehose is similar. It's just that Firehose is really serverless. So it's really serverless. So it's like a fully managed delivery service for streaming data. In this case, um, all like in the case of Kinesis data stream, you have to more or less like provision your capacity. But in Firehose, you don't provision anything. You don't. You basically just tell it a source where you're getting the data from, and then sometimes you can have like optional transformers that transforms the data. But the most important thing is you choose a source, you choose a destination, and then it aggregates the data in near real time and pushes it to whatever destination that you choose, right? So no code required, point and click configuration, meaning that, yeah, if you don't really need to transform the data, you basically could just have the data just come in and then go somewhere else, right? So automatic scaling and data transformation, right? And then delivery to S3, Redshift, Elasticsearch, and third-party services, and near real-time delivery. That's why I said the difference between data streams and Firehose, there's one is near real-time, because here there is like an aggregation that has to be done before the data is pushed to the destination, right? But for data stream, it's real-time, because as it's coming, something is consuming it, okay? Built-in data format conversion and compression. So those are the two things I just want to mention about Kinesis data streams and Firehose at this point, okay? Depending on how long my slide is, but if I go to Firehose, for example, so if I do Firehose and I go to Firehose, I can't create anything for this class, right? Like I said, sometimes because it's a beginner's class, I try to create some, the things that I know I can just quickly show you as beginner, but the things I also cannot show you as beginner, I'll just leave them for now until we get to that point, right? But the whole idea is really how it works, you ingest, right? And there's like an optional step to transform, right? And then you deliver, right? But one thing you need to um, pay close attention to is the fact that the places you deliver to are kind of like very strategic, and that's where sometimes even in the exam it gets tricky, because you can see such as S3, OpenSearch, Redshift, Splunk, Snowflake, or a custom HTTP endpoint, right? So it basically takes data from somewhere, whether it's from direct puts, whether it's directly from like a streaming service. It comes to Firehose, all right? Optionally, you can choose to transform it, and once that transformation is done, it's delivered. That's really how Firehose works, but it's serverless. You don't need to provision anything. No provision is happening there. Fantastic service. But if you look at the other more or less like the data stream, it's different, because the ways the data stream itself works. So if you go to Kinesis data stream, for example, I'm just doing this just to add extra context. So if you wanted to create a stream, it shows you how the stream works. And for many of you that have free tier account, if you wanted, you can actually go back here and look at it. But if you look at how Kinesis data stream works, really, it collects and stores data streams, right? So there's a collection and there's a storing. It actually stores it, right? For Firehose, it's batching it and sending it somewhere. But here it's storing till a consumer takes it out. Okay, it's like a mini queue that it keeps for you. And aggregate. So collect gigabytes of data per second and make it available for processing, analyzing in real time. Meaning that once you have enough consumers, enough producers, they can continually be producing, and the consumers are taking it right in real time. Okay. I hope I've been able to more or less like introduce you to data stream and Firehose. Okay, both of them are kind of similar. It just depends on what you are using them for. One is really fully serverless, so Firehose you don't need to specify anything. It scales for on your behalf. Kinesis data streams, yes, you need to. So if I was to create a stream on demand, you can pretty much like create shards, right? So shards are the things that shows how powerful your streaming is, because for example, there is like how much record one shard can take, right? So now depending on how much you want to process, you can have multiple shard. You can increase the complexity of your input through sharding, right? But again, these are not things I want to discuss right now. We'll just go back to the slide. But that's basically in a nutshell the difference between Firehose and so one is near real time, one is real time, one is purely serverless, right? And Firehose is purely serverless. And Firehose also has like very specific destinations you can send in data. But data stream basically is like a producer consumer architecture. So something has to consume it, right? Which in this case you can have like a code that is consuming it. Okay, so let's go to the next slide. So yeah, I did draw a sample architecture. Here it works. So you, for example, this is here it says like there's an event bridge, right, that invokes something. So more or less like event bridge is just yeah, you can something trigger something, right, every minute, and then that calls like a lambda in this case, right? So which is just like a generator. It's generating data. Where would that go? That has to go to a data stream, right? So it's going to a data stream. Maybe that stream is also that stream can actually be consumed directly by a consumer, right? Which in this case can be another application. But in this case, the example that I have here is that even the data stream can become a source for Firehose. And then Firehose can obviously optionally use a Lambda function to do more or less like the transformation on top of the data, right? But just think about it's still analysis that is happening in real time, right? And then Firehose can obviously move that file directly once it's done with the transformation to S3. And then on top of S3, we know that once the data get to S3, right, in as much as it's in the file that is expected, we can pull that data, right? So you can have like a crawler. So just think about it at 5 and 6, I've already showed you on the call. So because if the data gets to S3, you can automatically just push that into update the catalog and automatically just query that with Athena, right? So these are some patterns we are going to be seeing with time, and there will be videos and lessons that can show you this. So when you now think about video streams, it's the same. So data stream is basically data, but video is specifically for you to stream videos, right? So real-time and batch video processing, automatic scaling and durable storage. You can have AI and ML services for analyzing the video in real time, right? Or basically in real time. So think about it like you have videos that you're bringing up from your security camera footage, and you're trying to identify things and understand exactly what's going from those video footage that you're seeing in real time. That's where Kinesis video stream comes in. Okay, so for now, I'm just introducing the service. We won't be able to do something like significant right now at this level. Okay. That brings us to OpenSearch. OpenSearch is basically, we know, I think I've also told you, I've shared this foundation for you, the fact that many of the services you see in the cloud, they are not native to the cloud. There are some services that are native to the cloud. That DynamoDB is native. We saw, which other service was I talking about just now that is basically native? That's AWS tool. But when you look at search, people have been dealing with search before the cloud, right? And if you know, if you've worked with Elasticsearch before, right? So we know that usually you keep files there, just because you want to index them, because some databases are just better with some things, right? So if you know this is like things you want to search faster, instead of you keeping it in a relational database, it's better to just put it in a search database, a database that is optimized for searching, right? So if you were already doing Elasticsearch, for example, on-premise, and you needed to host an Elasticsearch cluster in AWS, that's when you need an OpenSearch service, right? So it's called Amazon OpenSearch Service, managed search and analytics engine, obviously successor to Amazon Elasticsearch Service. It used to be called Elasticsearch Service, but now it's OpenSearch, right? So real-time search, monitoring and analysis. So it means, yeah, it's the same. It's a database, basically. It's just a store for your search needs, right? Supports OpenSearch and then the legacy Elasticsearch APIs. Integrated with Kibana for visualization. So once you create an OpenSearch dashboard in AWS, you automatically just get a Kibana. If you know Kibana is basically a visualization on top of OpenSearch, right? Or Elasticsearch that you can use to visualize your data. But immediately you create an Amazon OpenSearch service, you have a UI, a dashboard that you can basically just go and start doing the same things you were doing with Kibana, right? Use cases, log analytics, right? So OpenSearch, one of the use cases for OpenSearch is usually to store your log data. And there's so many logs, container logs, application logs, whether it's infra side, whether it's application side, log is being aggregated, and you can do advanced queries, dashboard, visualizations from OpenSearch on your log data. Okay, so application monitoring, obviously, if you are in the cloud space or DevOps space, you know that, yeah, if you want to monitor your application, there are logs from your application that needs to be stored somewhere, and that needs to be it has to be stored in a data store that can support you being able to quickly search, quickly build visualizations on top of it, right? Yeah, for searching also. So on the application side, you can also put things here in your search database for things that you know that you're going to query, and you want to get them as fast as possible. So when you now think about the analytics architecture that we have looked at, right? So when you think about ingestion, that's when you talk about Kinesis, right? So Kinesis will do all the ingestion for you. You can build an API on top of that, where somebody is using an API to do the call, but you can also do direct calls on those. Like you can use Boto3, for example, to just put data into like a Kinesis data stream or like a Firehose, right? So but yeah, that's like you can do ingestion around that area. Storage, we've seen S3, obviously data lake is something else that is different that we've not talked about, but that's an option. Redshift obviously can store data if you wanted to do like huge warehousing, right? Processing, Glue ETL. Right now, I think we just talked about crawler, but there's so much to Glue. You can actually have, you can do all sort of things, right, with ETL jobs, right? And then EMR is obviously Hadoop, Spark, and then Lambda functions if you wanted, because at some point, yes, Lambda is always in the mix. If you wanted to do like event-driven architectures, your file, you push something to your file, a Lambda function is updated. A Lambda function is watching for that event. It triggers a crawler. A crawler updates your S3, gets your S3 files, updates your Glue catalog. Athena queries begins to run using the new schema that is out there. And then there's like a visualization, maybe like a quick site dashboard that is also refreshed because of that pipeline. Okay. Analysis, like I said, you could have Athena queries and all that can be bubbled up to a quick site, and then you can obviously do Redshift analytics itself, right? So if you were using Redshift, visualization, quick site dashboards, and third-party BI tools. Remember, quick site is AWS on, but you can also have your own tool and deploy it and use the same things to. And then data governance, Glue catalog can help you manage that, right? So it just tells you how data is, I think for us, like if you're just starting, you may not care so much, but for people who are really data, like who data is their thing, they begin to treat data like code also, version, there's governance around it, and that's where Glue data catalog can really help you. Okay, there's just a lot around it. So when you now think about all the things we talked about, real time and then batch analytics, what's the difference, right? So batch, when you're doing analysis and it's happening batch, obviously it takes time, right? So real time is really is obviously the latency is very low, right? Milliseconds to seconds, right? Data volumes, continuous streams on one side, but for batch, it's really large data sets that we're talking about, right? So use cases, and think about it. For real time, for fraud detection, you probably want real time because you don't want something that you're detecting after like an hour ago, right? You want something that is pretty much real time. You're just getting it and analyzing it, and then if you catch a case of fraud, you can just flag it immediately, right? But batch obviously is you're doing business reporting, you're trying to find trends, that's like some good use cases, right? So when you think about AWS services for real time, obviously Kinesis is one, Lambda is one, right? Like I said, if we're going around the route of event-driven architecture, you want to know when something changes, right? Or you were analyzing something and there was like a Lambda function that was doing some transformation around it, right? So Lambda is going to work there. But if you think about batch analytics, Redshift cluster, the data is there. You can obviously do BI or whatever you want to do on top of that data. So it's not that much real time, right? And then EMR, Athena, they're all that are just for batch analysis, like we've seen. So we didn't really do anything around, real time analytics of that data. Complexity, obviously, like we saw, that's why it was easy to demo, right? Athena, when you do batch analytics, it's obviously the complexity is very low. We saw it. But again, if you have to do real-time analytics, there's higher complexity because you need to build that pipeline, right? Where's your source? Where's your source? What's happening to it? And then it says destination. Is someone being notified of an event? So obviously, one is obviously higher, right? Because you are doing that as the data is coming in. But the other one is already data that is at rest, and you're just doing analysis on it. And sometimes it's just about how much data you are requesting. If you're requesting few data, you pay for only that few data that you're requesting, right? Pretty much that is it. So if you look at data and security, all these services that we've provided, like we've seen for all the AWS services, there's room for data security, right? So encryption at rest, in transit, VPC isolation. You can also use private endpoints, right? So VPC endpoints is something we're going to see once we start talking about VPC. IAM rules, we saw how an IAM rule for the Glue, for example, was given access, specifically given access to the S3 bucket, right? If that access is not there, you can't access it. So everything is still built in a way that access is still controlled. You still can do encryption, right? Data masking and tokenization, especially around Glue, if you wanted to do that for sensitive data, audit logging with CloudTrail integration. For example, all the things that I'm doing when I'm running the Glue crawler, all that is captured with CloudTrail, and you can go back and see who is doing what in your account, right? And then compliance certifications. Obviously, we're talking everything we talk around this subject is about data, right? So until sometimes you need to be compliant, SOC compliant, PCI, DSS, HIPAA, right? These are all different compliance that you need to meet depending on which data you're dealing with. But there's obviously support for you to make sure that everything is covered, right? So for summary, we talked about the difference, right? OLAP versus OLTP, really different database types for different use case, right? OLAP is for analytics, OLTP is for transactions. Redshift, obviously managed warehouse with serverless, there's a serverless option for it. Athena, we've seen it, serverless SQL queries on S3 data lakes, right? So S3 data basically. QuickSight, a BI that you can have on top of all the things that we've mentioned, whether it's Redshift, whether it's S3, you can whether it's S3 Athena, you can obviously have BI with the help of QuickSight on top of it. And then Kinesis, if you're ever talking about real time or near real time streaming, that's where Kinesis comes in. And then obviously combination, right? So as you get familiar with these services, a lot of times you need to combine one or two services, three services, four services, five, combine all of them to build a pipeline for you to, And some of these areas obviously are more, stretched if you are going to specialize around data, or especially around data. Machine learning too will test you on some of these areas, because data, machine learning, they are all together, right? That brings us to the end of this class.